Hello, my name is Mohan Raj. I am a professor in environmental sciences at Bharatdasan University. Today we are going to discuss about the models that are applied in environmental impact assessment. Before getting into the actual modeling, I will just brief about what is environmental impact assessment and how it is carried out, and using models how the environmental impact assessment become more proficient and then more accurate and precise. Environmental impact assessment is a process, or it can be a management tool that is applied for to study the impact of the proposed projects or the proposed development activity on the environment, ecology, and human health. And once the impact is identified, then appropriate mitigatory measures are suggested to either minimize the environmental impact or to avoid the adverse impact on the environment by the proposed project. So in the process, the environmental impacts of the proposed development projects are systematically analyzed. In fact, the data is collected, analyzed, and presented in a form to facilitate the decision making. So in that process, then EIA is a tool to be applied for the environmental governance. So basically the impact assessment starts with the identification of impacts and then followed by the evaluation and prediction of impact. So the baseline parameters like air quality, water quality, soil status, land use pattern, all these environmental attributes will be studied before setting up of the project or before the commencement of the project. And during this stage, many of the data, that is many of the attributes which represents the environment, is being collected as a data in the Excel format, and then those attributes in terms of data, which are in terms of data, are analyzed by various software and various methods. So, and then they are presented in a more understandable manner to the decision-making authority or a committee which decides on the environmental clearance or environmental governance. So in the process, the identification of the impacts or the likely impacts that are predicted by various methods. The most commonly used one is the checklist, matrix, GIS, overlays, and the risk assessment methods. So you can see in the picture that the checklists and matrix and networks are more like qualitative assessments, whereas the models and overlays are more of quantitative. So which means that the data that are presented to the decision-making authority is much more quantitative information rather than qualitative. So here you can see an example of the matrix, which is of more qualitative. Here you can see, for example, here for example, you can see these are the development projects like airport, rapid transit, or highways, or whatever it may be. These are the you can see the development projects on this side on the whereas you can see the impact of these projects on the environmental components or attributes like surface water quality, air quality, land quality. And here we decide based on the three indicators, that is like whether it is significant impact or moderate impact or insignificant impact. If the impact is significant, um, maybe on ecology or air quality or water quality, then the project is considered as the one which causes the adverse impact, and then there are likely chances of this project getting either rejected or consider or to be considered in terms of more environmentally destructive, or it can or it should have more mitigatory, come up with more mitigatory measures. So this is another type of analytical method or a prediction method, which is called as network model, the networking. Here, you can see, for example, it is much more informative than matrix, where in matrix, say for example, if there is a water pollution, you just will we just will have a idea that whether that it is significantly affected or moderately affected, or it is insignificant, the effect on water quality. But whereas in case of the network, you can see the more information is generated in the network diagram, where, for example, you can see the water pollution, oily discharges from the boats, and then from the boat jetties. So like that, the secondary and tertiary impacts are also addressed in the the network linkages. So this has much more an upper edge on the matrix method. And also, there is another method to assess or predict the impacts of the development project on the environment, that is modeling. And a model is something that which mimics the real world, or a model could be a theory, a law, hypothesis, or an equation, or even a structured idea. So the modeling involves basically the mathematical and numerical techniques. The model tries to simulate the real world situations with mathematical equations to forecast or predict the future behavior. It is an analytical tool which enables the quantification of impacts which can affect the environment by simulating the environmental conditions. As I mentioned, um, you get more of quantitative information compared to the checklist and network method. Here we can really figure out what sort of impact in terms of the quantity. For example, what will be the water pollution? What could be the water pollution? Is it in the safe level, or is it in the higher level? Or we can even have a sort of range in the range while predicting, while try to assess the impact through modeling. So the most of the models use the computer technology to predict the chemical or physical effects of a particular action within the environment. So actually, the model is one software, kind of software, or a kind of analytical equation, which will have some inputs, and then some sort of coefficients, and which will get you, and then the output will be of the desired parameter. So for which it may need some sort of field work monitoring and collating the existing records, like, say, for example, the emission inventory or the inventory of the industries which are likely to cause impact on the water quality in a given location, and so on. And the model tries to establish the relation via the mathematical equations, and then the model needs to be calibrated if at all there is any sort of mishaps or shortfalls. The model has to get calibrated, and then again the models are likely to get verified with the real world conditions. And also, the difference between the simulated data and the observed data can again be the calibrated to some extent to almost make the real world conditions. A model is something, it always tries to be accurate, but still it may be slightly variable from the, it may be slightly varying from the real world conditions. So, for example, in the EIA, or in while assessing the impact of a proposed project on the environment, For example, if the project is likely to come up in a forested area or a protected area where there is kind of vegetation or a forest or even agricultural land, the normalized difference vegetation index (NDVI) is used to model the abundance of the living plant from the satellite data. You can see the NDVI is this is the equation for NDVI, where you can see NIR is the reflection in the near infrared spectrum and RED is the reflection in the red range of spectrum. So a vegetation index is an indicator that describes the greenness. Actually, while analyzing the baseline parameters such as the forest conditions, or if there is any loss of vegetation, or if there is any change in vegetation over a period of time, the satellite imageries could give you the idea how much change had occurred over the period of time. For example, if the vegetation index is an indicator that describes the greenness and the relative density and the high health of the vegetation. For example, each picture of an element or a pixel in a satellite image, actually the vegetation reflects the visible and infrared radiation. And based on these reflections, we can have a values ranging from 1 to -1, +1 to -1. If the value is plus, then it represents that the vegetation is very healthy and it is very green, whereas 0.1 or less shows that very low values, and in fact there is no good healthy vegetation in the area. So this is the the NDVI, how the NDVI data is generated. You can see the reflections from the healthy vegetations. You can see the near infrared 50%, whereas in case of the unhealthy vegetation like this, if at all there is a pest or if there is a drought situation where the vegetation is getting degraded, you can see the reflection is very less in the near infrared spectrum and also in the infrared visible spectrum. So these values are computed, and then we can arrive at a conclusion that this vegetation is already affected or it's affected by air pollution or whatever it may be. So this is a sort of example for you. And again, the satellite data is used for the spatial modeling and finding relationship among the geographical features and to understand the thematic issues, or it can generate the thematic maps. For example, it can be like we can generate special maps or thematic maps for the streets, cities, or the water bodies, or even in the case of oceans where there is algal blooms are available, or within the cities where all you have a low-lying area where it can be inundated. So such thematic maps can be generated using the spatial data, and there are many models that are being used in the spatial data analysis, and most of them are GIS based models. And here, for example, even we can use the land suitability model. For example, here in the case, if you want to have a buffer zone in the forest, or if a road is trying to be laid in the periphery of the forest or in the middle of the forest, we can really generate a kind of buffer zone and then identify the suitable areas or for the buffering activity or something like that. Here, for example, you can see, so this is the road. Like this, we can have a kind of restricted area, and we can identify this buffer zone that is 300 meters or so within the highway. So like that, the spatial models are being used in EIA to predict the buffer zone or to identify the buffer zone and and also these kind of suggestions can minimize the impact caused by the project, like a road development project. So you can even have a kind of overlay and see between the, for example, a railway line or a road line, where all, or a pipeline or a gas pipeline, which can it can be overlaid. A different sort of development activity or a can be overlaid and viewed like this in the spatial models. So like this, we can try to generate suitable areas for harvesting. So there is again another model which is being widely used now, that is the digital elevation model in GIS. And this model will have Z, X, Y, and Z, a 3D model where we can really identify, for example, if the factory is located somewhere here, and what sort of pollution, water pollution is expected in the downstream, and to which end, to which direction, to which location there is a likely impact, can be analyzed using the digital elevation model. And there are also many models which are applied in the weather forecasting, and which is also will be very useful for the predicting the impacts of a development project as far as weather parameters or meteorological parameters are concerned. So, for example, Thyssian polygon is one thing which could predict the likely rainfall abundance in an area, or the likely rainfall distribution in an area, and which is through the polygons, which you can see in the right side. And also, in fact, if there is a cement industry or if there is an oil refinery is coming up in a given location, the air pollution dispersion models can be used to assess the likely impact of this industry on the downwind direction, or on a given location, how far the location which is downward towards the industry is located, and to what extent, or to what levels the concentration of pollutants will be accumulated in that area. So that is like basically a Gaussian plume model, which will predict the concentrations of the point source dispersion. So these models are typically used in the permitting process to estimate the concentration of pollutant at a specified ground level receptor surrounding an emission source. And there is also another model which is being widely used. There is the receptor modeling. These models are mostly used in EIA. These models try to use the observations that are made using an air pollution capture devices or the air monitoring instruments. The data from the air monitoring instruments can be used in the receptor model, like chemical mass balance model, or a kind of the positive matrix factorization model, or even a simple PCA, that is a principal component analysis. Using all these kind of models, statistical and mathematical models, we can identify the source and from where these pollutants are coming. For example, if you have polyaromatic hydrocarbons in the data, the model can specifically give the idea about the source from where it is being generated, either from the vehicular emissions or from the kitchen emissions or from the incinerator, or any source like that. So this can really give the idea about the emissions from the sources. So here AERMOD is the most widely used model for the point source dispersion. That is, it has two components in that: AERMET and AERMAP. AERMET is nothing but which will have the meteorological data as input, like the wind speed, wind direction, solar radiation, etc. And the air map is nothing but it is another component which will have inputs of terrain data, that is DEM, the digital elevation model, which I showed you earlier, and then the pollution data, like the emission source, the data from the emission source in terms of emission rate or geometric parameters, and this will calculate and give a result on the concentrations of the air pollution at a given location. So this is one model which is being widely used to predict the impact of air pollution from an industry or from a stack chimney, etc. So this is how the AERMOD generates the data for you. You can see in what direction it moves. And there is again another model which is being widely used, that is CAMAX. CAMAX is a comprehensive air quality model, which is a multi-scale, three-dimensional photochemical grid model. This model contains two-way grid nesting, subgrid, two-min grid. And the one advantage in this model is it can give you even the pollutant-wise, for example, the PM10 or ozone or whatever. And it is also, this model also uses the different kinds of data. It can even give you the secondary pollutants like ozone or the photochemical smog, etc. The emissions, you can see the emission inventory here, which is given as an input, and same like the other one, meteorological parameters and topographical parameters as a given as an input, and then photolysis coefficients or the constants are given, and then the land cover, the terrain data is given as an input, and finally the model predicts the impact in terms of different pollutants. And again, there is another package which is an open source package that is based in the R platform. This is in fact is widely used to find out the either dispersion of pollutants from a source, from a given location, or from the monitoring stations towards the downwind directions. And then it can also, if you have a kind of hourly data or even like data which represents for many years, this model is very useful to have an understanding of the baseline information of a given location. For example, if an area has got 10 years of air pollution data and the wind speed or the meteorological data, wind speed, wind direction, and other meteorological data, or can analyze and give you for example, the data like this. It can present in a very easily understandable manner. Like you can see the weekly data is being presented here, and that too you have a kind of what is the pollution levels in the morning, during the peak hours, and during the night, and it is also given here, and weekday. So it can also give you for the different pollutants like PM10, PM2, whatever maybe the pollutant, you can generate graphs like this for hour-wise, year-wise, and also weekdays. So the open air also can give you the pollution dispersion, maybe in which direction the pollution moves out and what will be the concentration. You can even, it's very clear, and this can also be overlaid over coupled with the GIS data, and we can figure out which particular location will have for example, here in this whichever is shown as red has got a very high particulate matter, that is more than 90 microgram per meter cube of PM 2.5. So similarly, there are water quality models which are being used to predict the impact of industry or a development activity on the surface water or groundwater whatever it, or anywhere, even inside the marine environment, if there is a leakage or if there is a dispersion of pollutants in the marine environment, we can use models, different models, and analyze the impact of pollution. So the so these models generally simulate the freshwater, brackish water, whatever may be the, and many models focus on the water chemistry, pollutant dispersion, the concentration of pollutants. So it depends on what sort of information we require. So we can choose the model accordingly. Um, for example, whether you need to get it in the spatial analysis, or you need a kind of 1D or 2D or three-dimensional data. So these are the models that are available to predict the water quality. And then here the most widely used is C equal W2, which is developed from the US EPA, or it's available, and the original model website is there in this slide. And you can see here in this picture, QualCUT is a model that can greatly facilitate addressing the water quality management issues at the mainstream projects. It's mechanistically models the basic physical, chemical, and biological processes: temperature, nutrient, algae, dissolved oxygen, organic matter, and sediment relationship. Once applied and calibrated, the model can reliably predict the reservoir water quality conditions based on the changes in the environmental conditions or the project operation and regulation. So even in the reservoir, you can apply this model, and we can find out the transport of pollutant and dispersion of pollutants. For example, in nitrogen, what is the nitrogen and how does it disperses? Different pollutant will have different kind of transport depending upon their the chemical and physical characteristics. So the C equal to W2 is a two-dimensional model. It is like horizontal and vertical. It is best suited for relatively low, long, and narrow water bodies. So depending upon the water body, you can choose the models. So this is the another picture which shows that which model is being widely used and the scope. Here again we can see the C equal W2 is a very widely used model, and it's a 2D model. And you can see the element cycles of oxygen, carbon, nitrogen, phosphorus, and iron. And the processes like temperature, pH, dissolved oxygen, phytoplankton. So for if at all we are interested in all these parameters, so this called W2 is the best suited model for the analysis. So these are basically the models which we had seen to study the impact of air quality, water quality, and also the spatial extension of the impacts. So thank you very much.